Hi, everyone. Thanks so much for joining us today for the Testing Strategies for Docker-Driven Development webinar. We're really glad you could be here. As for our presenters today, we have two companies presenting. We have Daniël van Gils, a developer advocate at Cloud 66. And then we also are going to have Alexei Ledenev, software architect from Codefresh, going to be speaking shortly after. As for the agenda, Daniel's going to kick it off and talk about Docker inside and out, the real world of stacking containers in production. And then he's going to pass it over to Alexei, who will dive into testing strategies for Docker-driven development. And we should have time at the end for a Q&A session. So if you have any questions during the presentation, you can type them in the question box and your GoToWebinar control panel, and we'll try to get to all of those if we have time. If not, we'll definitely follow up with you directly. So with that said, I will pass it over to Daniël.
So, hello everybody. Let's start the presentation. Get everything up and running. So, good morning, good afternoon, or good evening, depending on where you are. So, I'm presenting from the Netherlands, and so my presentation is going to be the real world of stacking containers in production. And if you look at my first slide, you can see this container falling up and down. If you visit the Netherlands once and you go to the Rotterdam Harbor, in the entrance of the Rotterdam Harbor, you find the sculpture. And this also presents a little bit the last 3 years when I'm getting into containers and joined Cloud 66, working with containers and still learning day by day. And this presentation will be about the whole journey from starting with nothing till running containers in production, all the learnings. So at Cloud 66, so we provide a platform to run containers in production on any cloud or on your own server. So first, let me tell a little bit what a development advocate does, or in my opinion, what I do in the companies like Cloud 66. So on the left side, you can see me spending time, like 50% of my time, building, shaping, creating, killing darlings, creating darlings, deploying containers in production easy. And on the right side, this is the other half of my time. I'm spending about thinking about containers, researching it, talking to the public, doing webinars, helping customer support, and try to understand the ecosystem and where the whole cloud native goes to, and trying to make sense of it. And when I think about solutions, I can bring it back to the product. So for today, I'm gonna take you on a journey. And if you look at lots of blockbusters, like for example, A Lord of the Rings, they all use this this kind of archetype or this kind of design pattern, how they tell stories. And you have this guy called Joseph Campbell. He wrote this book called The Hero with 1,000 Faces. And basically this is an outline how you go from nothing to hero and what kind of transitions you make during that narrative. And the interesting thing is that you can apply this hero journey also how you learn containers and bringing containers into production. So my presentation consists of 12 stages of the hero's journey, and we'll talk about what you find on this journey to running containers in production. So let's start with this diagram. So basically, we all live in this ordinary IT world, right? So where we already do like continuous integration, building stuff, deploying things on servers, and doing Scrum our ass off, putting posters on the wall, all those things. So we're all doing this, you know, what I call the ordinary IT world. And but if you want to go into containers from day one, you can't deploy anything in production. There's like a learning curve. So on this in my schema, on the left side you see one container, and at the top you see like the whole thing running in production. And so if we look at what's going to happen when you start using containers. So first of all, in this journey, well, we start with ordinary world, what I'm talking about, and then suddenly maybe there's a call to adventure. So if you look at like Lord of the Rings, then there's something happening. The dwarves comes in and they say, "Oh, we want to go on a mission," and that's a call to adventure. So if you translate to the ordinary IT, well, probably your coworker comes by your desk and says, "Yeah, I went to this great conference and we're all talking containers, and we should use the containers, Docker, Kubernetes, microservices. We have to go like cloud native, all that stuff." And you're like, okay. So how are we going to do this? And the first thing is that most of the time you refuse of the call. You're like, well, wait, I have to finish this part of code, and how do we can integrate it in our pipeline? So there's a little bit of refusal of the call, and you need a little bit of push, right? So that's the moment where you're meeting the mentor, somebody who says, or maybe a coworker or yourself, or somebody from another company saying, okay, you know, if you want to deploy containers in production, maybe you can start with this. And in my presentation, I will be the mentor for you today, and show you a little bit of hand-holding what to do next. And if you look at this diagram, you already see that it's already started the journey, and it's going ups and downs. So sometimes it goes positive, sometimes it goes negative, but in the end, if you keep on the pace, in the end, you will deploying good stable containers in production. So let's start with this. So I came up with this model. It's called the artichoke model. And if you look at an artichoke, the sweet stuff is the heart of the artichoke. There's a lot of layers around it. But if you pull all the layers, you actually can see the heart. And if you apply that to developers, for instance, so developer, yes, like a nice IDE, all this tooling, but in the end, if you look at the heart, you just want to write elegant, performant code and solve problems for the user. For the operations guy, it's the same thing. So you're going to talk about servers and speed and SSD and RAID systems and what not. In the end, an operations guy, he wants to have like 24/7 uptime. He wants to have a stable system, all that stuff. And I think which is interesting in this container world is that the image, the base of the container, is basically a communication between those people, and also business. The business wants a return on investment, all that stuff. But in the end, it wants to have changed. They want to bring value to the customers and value to the company. And they want to do the agile. They want to just say, okay, I just want to change something to the product. Can you just change it? So maybe we can change that little service there. And also for people who are using your service, they just want to use your service. And the nice thing is that if somebody requests a feature, and you can easily switch your container, one of your containers, you make your customers happy. And also other entities in your company have the same thing. So in this story, the first thing what you're going to do is crossing the threshold. So you step out of the ordinary IT world. So you know as becoming a hero, you know, okay, we need these containers. It's going to provide us a lot of cool things. And so we're stepping in this very special container world. So it's an unknown world. And before we can, the first thing you encounter is what I called the containerization machine. And the containerization machine is basically the process of taking your code and generating your images, which are the base for your container. So you're bringing the code and you're generating those images. So the first thing with your team is to understand this process, to understand the containerization machine. And also, this containerization machine will also, testing is also a part of it. So Alexei will talk about how you can, containerize your application and do all the testing stages. So let's give again a brief, small introduction to containers. So we have a very clever kernel. Like a couple of years back, I tried to run containers without Docker, and that was hard. And with Docker and with new container runtime, it's very easy. So basically, we have a very, very clever kernel, and on top we can run containers. And basically, a container is just an isolated process. So a container, what runs in a container is an isolated process. And if we want to define how to run the container, we use a Docker file. And basically, this is what the Docker file does. So from base is basically your base system. It can be like maybe an Ubuntu root image or Alpine, which is really small, but it starts with a base to start with. Then you run your updates, set up your compile time dependencies and all the stuff you need to build your code. And you can see that your image is getting bigger. On the right side, you can see that your image is getting bigger. Then you copy your source code, and then you create your source code, just compile it, do all the things you need, do some cleanup, maybe remove some secrets, all that stuff. And then basically you tell the container how to run this code. A thing which I see in the wild is that a lot of customers doing is what I'm trying to say, think global, egg local, is that you can't, if you create a Docker file, you can't just give the Docker file to a system and just deploy it. So what I'm always telling my customers is just get your Docker file, build them locally, just understand how a Docker file looks like, how it works, all the ins and outs, and then when you have your system up and running on your local machine, then go to your continuous integration system and all that stuff. So you see a lot of customers just say, oh, I have this nice Node application, I have a Docker file, just deploy it. But they don't know what is happening in that Docker file. It's really good to understand what's happening with the Docker file. So we're now in this very special container world. And this is the moment where you have you get tested. You're going to create your first Docker file. You make some mistakes. You find nice resources on the internet. You go to conferences, get yourself educated. Sometimes you try to do something and you create enemies. Not enemies as persons, but you're trying to achieve something with your Docker file, maybe your Docker Compose and all that stuff. And what I see with a lot of customers is that when they run into problems, if it's really difficult, you're probably doing it wrong. And we all know that from if you are a developer, that sometimes taking a little bit of distance and look at the problem, probably the solution is much simpler. And this, oh, sorry, one back. This is also what I see a lot with my customers. I didn't have time to create a SLIM image, so I created a fat one instead. So that's the thing. A container is just an isolated process. Don't treat them like VMs. So it's really good to only put the things in your image, run your container, what you need. So of course, in the first steps, it's really easy just to create everything inside the container and just doing everything. But in the end, in production, you probably want to end up with a SLIM image. So shortcuts are evil. So take your time and try to achieve the SLIM image instead of a fat one. So less is more in this case. So if you look at the containerization machine here, again, then we create containerization, we understand how to create the Docker file, so we're progressing here, and we're putting in our code. But you have to understand, if you put in shit, you can create a nice image, but in the end, the production is still shit. You can't polish a turd, so you make sure that when you create your images, they are ready to go. And So in this story, when you have like the approach is the moment where you going to deploy in production. This is the moment where you take all the test learnings, enemies, allies together to fight and to understand this thing and run things in production. And this is what I called kisses to get it right. So kisses, keep it simple, stupid. And I say keep images, and I have five things: keep it slim, secure, speedy, stable, and set. So on the left side, this is what I'm talking about. That's a fat image, and on the right side you see a slim image. With slim, I mean just remove everything you don't need. With secure, I mean just remove your secrets. Don't leave things hanging around. With speedy, it's always good to test your containers, like do some load testing on your containers to understand how your container is behaving. It doesn't matter if you have like the nicest orchestration system where you deploy your containers. If you don't understand how your container is behaving in production, you're screwed anyways. It doesn't matter if it has nice auto scale and all that stuff. So make sure you understand what your container is doing. And also stable, make sure that your base images are not pulling from the latest tag, but make sure that you put in a versioning. And also set. So the thing is, I mean, in an orchestration system where you deploy your containers, you don't know where your volumes are. Maybe you probably use like DNS-based service discovery. So don't do hard-coded things in your image. Just treat them like immutable containers. So this is the moment. This is the moment in the story. This is the moment where we have the big fight in a movie. This is the moment where you're going to deploy in production. And so you get your image right. Now you go into production. So now what? So you need something to deploy to. But before we can talk about that, let's talk about reality. So I did some research how our customers using Docker, and also I did a lot of interviews, and when I go to conference, I talk to a lot of people how they use containers in production. This is a little bit how people are using it. So 60% are still doing monolith containerization, just taking the whole monolith, just put it in one container and run it. I'm not saying that's wrong. I think it's part of the learning curve. Then you have like 30% doing API first approach, where they split the monolith into an API and maybe a front end. 7% is really, getting workers, API, some other background process, all that stuff. And about 3% are doing microservices. So if you go to conferences and reading it online, everybody says, oh, they're all doing microservices. It's not true. They're lying. A lot of people just have lots of legacy, and they're also using containers to deploy it. So, so when you start deploying into production, you know what's needed, you know what's going on, and this is probably what you're gonna experience when you're deploying, if you want to deploy things in production. So you need something like a container platform. So you need things like security. So how's the security around running your container, but also the security of your host? Data management. How do you run your databases? How do you back up your data? All that stuff. Orchestration. How do you spin up new nodes? Do the networking, bring them down, bring them up. Lifecycle. So this is of course where Codefresh and Classic6 comes in, when you can run your test and deploy it in production. Discovery. How do you find your different microservices? Monitoring. Especially when you go for microservice architecture, where you have lots of different containers, they're all outputting lots of logs. How can you, find the right information? And scaling, how can you scale up and scale down? And of course, scheduling. So when I want to run my container, where is it scheduled? Do I understand how it's scheduled? Does it have enough resources? All of these things are necessary in a container platform. It's kind of nursery, you have to take care of all those little containers. Of course, they're not like pets, but still you need something which takes care of all those. and then you understand what you need from the platform. So then you can, it's a road back. You go back to your, your daily job in the ordinary IT world, where you can discuss with maybe your CTO. You can say, okay, we have a proof of concept deployed in production. This is what we need for our for the whole company. So this is how we can implement it. And a note what I want to say is that create a little bit of headspace. There's a lot of things going on in this container ecosystem, and it's still evolving. I mean, first, every 3 months there's a new technology, there's a new volume driver, there's a new networking. So give something some time. Just pick the right, just pick your right battle. And also, if you choose a platform, maybe you are a big enterprise company and maybe you need the elephant, but maybe you're a startup and just need a small platform, but something in between. So make sure that you understand what you needed at this moment and how you can grow depending on your workload and all that stuff. So in this journey, this is resurrection. So you're a new man in the ordinary IT world, and basically containers are being part of the ordinary IT world again, and you return with knowledge. You return with, okay, we've done this, we have it running, you understand it, and now it's the ordinary IT world again. And the moment when there's a new technology comes out, you go on a new journey and find ups and downs, and crossing the thresholds, working to the ordeal and then the road back. So it's like an ongoing journey, learning new technology. So what I talked about today, so understanding this very special container world and make the transition to containers in your organization, you have to go on a journey, this hero journey. So you're going to be a hero in this one. Less is more. So make sure you're streamline the way you create a Docker file, understand the Docker file, understand the image. Make sure that you go from a fat image to a slim image. Understand the architect model. What things do the roles in your company need? So, and especially when developers and operations are getting closer and closer together. Basically, if you look at the Docker file, it's basically a collaboration between a developer and somebody who does the operation, or maybe you're doing both. But in the end, it brings all together. And a developer has to understand operations, and operations has to understand the developer. So it's all part of this DevOps thing. But I think the architect model understands what's really needed. And of course, give yourself a headspace and make the right choices. So thank you for listening to the real world of stacking containers in production. And I'll give back my microphone to Brittany, I think. Let me just.
So we'll actually pass it over to Alexei, who will give his talk on testing strategies for Docker containers.
Perfect.
Okay. Hello, guys. My name is Alexei Ledenev. I'm working for Codefresh. Also maintain a couple of open source projects related to Docker containers and testing, like Pumbaa, Scout testing, network emulation for Docker container. My latest stack for last 2 years is Docker, Go, and Amazon Cloud. I post regularly on my blog, Medium, and Twitter, so welcome to take a look. First, I would like to talk about the benefits of Docker for me, at least for me. What are most important things that Docker brings? The first one is portability. Actually, Docker is a portable container that packages any Linux application or service. A package can be created on developer's laptop using any language, any framework, any runtime, and can be run or modified on server machine, on public or private cloud, or bare metals. It's quite similar to what Java promised us more than 10 years ago, write once and run anywhere. But it's more robust in my opinion, and it's more generalized, like build once and run anywhere. Okay. It's also very fast. Comparing to previous virtualization technology, which was VM, Docker is actually process isolation, and you start container. Container is just a child process in your Linux machine. You start it in milliseconds. You need to start the process and some isolation around the process. Okay, network isolation, process isolation, file system, etc. Configuration. Docker is nice. It's also capture not only files and packages, but also configuration. So instead of installing and configure application on your server, you just make all configuration within the container, and you deploy your application with configuration file, with sometimes with data to server. It's actually simplifies the deployment stuff. And there is Docker registry or Docker hub. There are multiple registries. You can see it as a huge app store of ready-to-use containers, applications packaged for you to use. You can find there very useful components or tools that someone already packaged into containers. And if you need database or memcache or any other solution, you can find it there. Just use it as a Lego cubes. Okay, so a slide about Docker architecture. Daniel talked about the inside of the container. I'll talk about how Docker is built, what are core component of the Docker technology. So in the center we have a Docker host. It can be your local machine or some server machine with where main Docker daemon is running, and this Docker daemon is able to create these child processes called container from images. What is image? Image is actually a simple archive tar file that has all required files within it, including some additional metadata, how to create this child process and how to initiate it with environment variables and other stuff. Okay, we have a registry where we keep these archives with different versions where you can download them. And of course, you have an API and command line client that can control your Docker daemon. You can create a new image. You can pull existing image from registry. You can run the image, actually creating a container. And you can also save your container, modified container, as an image, as an archive. Okay. So you know how to build your containers, but there is a question how you're going to test your container, how to create a test lifecycle around the container. In my demo, I have a demo application and test. So demo application is a simple REST API server written in Golang. It's a very short one, about 50 lines of code, includes 2 or 3 methods and etc. That allows you to get some articles by ID or just all articles. It's written in Go, okay? And for test, I'm using a Postman. Postman is actually a REST API testing tools, which is a Chrome browser extension. And it has a command line companion called Newman. Newman is Node.js application that can read scenario files, test scenario files created by Postman, and can execute them without UI, actually with, on your build servers or other place. Let's go. When you first start with your container journey, you usually what most people do, they modify the existing pipeline. You have existing pipeline where developer commit the code and tests and in the code repository and CI server, which is able to compile your code, to execute test, and to package is a jar or RPM or Debian package, etc. So with Docker, people start to modify this flow a little bit. They add a Docker file, which actually described how to create this Docker package. Okay, and they just replace their standard jar or RPM packages with Docker container. The CI remains almost unmodified. You compile your code, you have all compilers, you have all testing tools installed on CI machine, you execute your test. Once it's ready, you take the binaries, put them into Docker container, Docker image, and deploy this image to the Docker registry. So from now on, you can deploy it to running environment. It's a pretty straightforward flow. I'll show how it looks like. You should be able to see my desk. So you start with compiling your code. In my case, it's Go application, so I do Go build and compile my application. You can see I have a binary compiled on my local machine. Now I can run the application to see that it's working. Okay, I run it in background. I run my tests, human tests. So the same flow it happens on CI machine. You see all tests passed, 5 requests. And now I can stop my running application, and I'm creating a Docker package to deploy the application. Okay. So I take in the Docker file, and I have an image. The small one with 6 megabyte image, very small one. Slim and secure, as Daniel asked you to do. Okay. So this is my deployment Docker file. It's actually start from scratch. It's even leaner than base image. Scratch means nothing. I don't need nothing for Go application. I just add my binary and that's all. So let's return to the slideshow. So what benefits and drawbacks of this naive approach? We are getting we still use the familiar CI flow, continuous integration flow. We are getting application portability. We can create Docker image. It can be a pretty small one if we try. But we are not getting a portable dev environment or test environment. Meaning we are not able to reproduce exactly the same development and testing environments outside of CI. To create a new test environment, you need to set up test tools, the correct version of these tools, and plugins, and configuration runtimes, and runtime environment, and environment setting, etc. So you need to repeat this procedure for each machine, developer machine, CI machine, new build agent machine. So it's quite tedious. What can we do better? Okay, let's try to improve the situation. So to improve the situation, the next step can be take all CI flow, like compile and test, and put them into a container together. Okay, the flow is the same, developer commit code, but right now CI server doesn't need any compile or test tool. Okay, you just need the Docker, you need the Docker there, and Docker file itself know how to bring the required compile tools and lint tools and test tools and create the image that contains everything. And this image can be pushed to the Docker registry to be deployed on runtime environment, test environment, so on. So let's take a look at the image. So as you see, the first lines, it's start from some image called Go Builder. It actually contains Go SDK plus some additional tools, lint tools, and compiler tools. it execute go build, so it can build the application. It also installed the Node.js and then the Newman, and create an entry point script where you can run your application or run your test, depending on command line parameters you pass to, command line arguments you pass to the Docker container. So let's take a look how it works. I'm switching to my terminal. I'm building the demo and test container, the same Docker file you saw. So first it's install required dependencies and compile the Go application. And then it install additional packages like Node.js and the packages Node.js depends on. Install Newman Node.js modules. And that's all. Now I have my images. Okay, it's quite a big image. It's 470 megabyte image. Right now I can run my test container if I pass the arguments tests. So you see all tests passed. I can also run the same container as an application, passing the demo argument. So I have it up and running. Let's see if it works. Okay, it returns welcome message. Just fine. I stopped the container. And that's all. Okay, let's return to the presentation. What we have now, we have simple CI flow, very simple one. We need only Docker on a build machine. No need to install any compilers, or build tools, or SDKs. You add additional build agent, just install Docker, that's all. You have application portability. You have portable dev and test environment. Actually, I can take this Docker file to any machine, new build machine, or any developer machine, you can, or QA machine. You can build your application there. All you need is Docker. You can also run your application there. Okay, it's pretty easy. We also capture test scripts at specific point in time, so we can always reproduce them in any environments. Actually, test their part of the image. You don't need to set up these testing tools in any place. Okay. What are drawbacks? We have a bigger Docker image size. Okay. We need to rebuild image each time we modify code or test. It's quite a polluted image. We have a lot of runtime environment with test-specific configuration, maybe introduce some unneeded dependency packages, and we need to decide how we manage test results, where we keep them, how we extract them from the container, and not a clean solution. Let's try to improve it. So to improve it a bit, it's still the same concept. We have one Docker file that contains application and test code, but we are also able to extract the layers. As Daniel showed you, that there are multiple layers in Docker image, so we will be able to extract layers that contains only application, and we have the bigger image that contains both application and test. How can we do it? I took the same Docker file as before, and with one significant addition. At the line 15 and 28, you can see there are two cmd command in Docker file which is unused. People not using this, since only one command is working. Okay, why I'm doing this? You can also see there is a special label. I call it split. Put anything you want. So I just use this label to catch the layer where this label is created. So I can split my image into two images. So I show how I can do this. Let's take a look. I call it test-aware container. So we are building this image. It's almost the same build as the previous one. We compile Go code, and you see here the label being created, download Node.js application, all required packages, Newman, and we have our image. We can see it. It's the same size as the previous image. Now we can run test in container. As previously, it's a test-aware container. All application test is running. Now let's try to find our split label. We are using Docker history command grep and ask to find the layer ID. And we use Docker tag command to mark this layer with new tag. So right now we have additional image, which is smaller. It's called have a up tag. Running this image, we are running on the application. It doesn't contains Node.js or Newman or tests. It contains only the application code and Go. Okay. This is the approach with test-aware container. Let's take a look at the benefits and drawbacks. Just a moment. I lose my mouse. Okay, I will not go to full screen. For some reason, I'm losing my mouse. So what are benefits and drawbacks? We have application portability. We have, as previously, we have portable test environment. We have two separate images, one for application and one for test. One image that also includes testing tools and tests, and single Docker file. Okay. The drawbacks is that we still image is somewhat big, and we need to rebuild it each time code or test is changing. And you need also to use some shell magic to extract this application layer, which is non-standard Docker way. We are using grep ask to find the image in history, layer in history, and tag it. So still there is a place to improve. After trying several approaches, in addition to those that I described you, the following is something that I can really recommend you. Okay, think about Docker lifecycle as an automation flow. Actually, you need to do a lot of stuff while you create your image. And the idea is Dockerize each step. Okay, if you have steps like build and scan your code and different kind of testing you are running, like functional test or security test or load tests, and the way you are deploying your image, not only pushing it to registry, but maybe you would like to deploy it to Amazon or Azure or some other cloud. And each step requires different tools, different runtimes, different packages, data, and configuration file. And the idea is to use Docker container for every step. For example, have a builder container that is used, contains all SDK and build tools like compiler, linters, and package managers to compile the application. You have a test containers, which include testing tools and tests to test your application, and application container that only contains the binaries and runtime required to execute these binaries. Let's take a look at the free files. I have there may be more than 3 files, but I prepared the 3 files. So I have a builder file which contains only the Go SDK, You have a test file which based on Alpine image and installed Node.js and Newman tool, and copy all tests from the code. And you have also an application file, which is actually very lean one, starting from scratch, and you add there only binary. Let's take a look how it works. So I'm starting with this flow. First, I built the builder image. Okay, it's image with all Go tools and source. Now I run this. You see the builder image is almost 400 megabyte. Now I run this builder image with mounted volume to create my application, to compile my application. I see the compiled file. It's a Linux binary file. I can take this Linux binary file and put it into Docker container for application deployment. It's a very small one, only 6 megabyte. And now I also built a test container with Node.js and Newman testing tool. It's 80 megabytes image, and I'm running my tests. Okay, creating some network, running the application, and running the test container. You see all tests passed, executed. So what we have right now, we have application portability. We have every single step is portable. Actually, you have a portable automation flow of Docker lifecycle. Okay, you can run this flow anywhere. You have a portable test environment, small application images, very fast builds. You only build the things that changed. If you modify test, you only need to rebuild your test container. Or if you modify code, you rebuild the code container, and the builder almost, till you're not switching to new version of tools, you don't need to rebuild it anyway. The drawbacks that you need to think about an approach or find a tool that help you to automate and orchestrate this build flow. Of course, you can use old shell script like Bash or Z shell, or things like Ansible that can help you to automate. I found them a little bit not easy to learn for everyone, not suitable for everyone. There are nice tool that allows you to define this build flow as in simple YAML files, like Adobe or Habitus. I believe it's from Cloud 66 open source project. Or use some Docker tailored CI/CD service like Codefresh does. There you can define this flow of multiple steps where each step is actually a Docker container. So here I'm finished. I'm saying that till now this is the best approach for me. It works, it's bulletproof, and I use it already for a year. Quite happy with it. Thank you guys for listening. Have any question, ask them, I'll try to answer. And I return the microphone back to Brittany.
Thanks, Alexei. So now we will open it up for questions. Let's see here. And if we open up the chat box, do you guys want to start? Let's see, we have Edmund D. Edmund, he asked, where does compliance and audit fit in the journey? And is that relevant here? Alexei or Daniel, do you want to try to answer that?
So can you repeat the question again?
Where does compliance and audit fit in the journey? Is that relevant here?
Well, I mean, audit is always relevant. I think if you look at building your images, but also when you deploy it into production, it's always good to have an audit trail and see what's going on. So it's because you need to know what's going on from developer point of view, but also in operations. What's running in production? Is it signed off? Who's having access to my platform? So I think it's going to be an integral part of getting things right and running things in production.
Okay, and someone else asked, is Newman a tool or an API, and is it open source?
Yes, it's actually a tool. It's a command line companion to Postman. Postman is a tool. Both are open source, and you can use them freely. And it's just do a npm install Newman, and you'll have it on your machine.
Okay. And so yeah, because that's the second question was where can I get it? Where could he find Newman?
Sorry?
And let's see. The other question was, Alexei, are we able to use Docker Compose to manage a Docker testing flow?
Docker Compose is more suitable to define a runtime environment than to define a flow. Okay, since everything started simultaneously, you create a common network, and the idea behind Docker Compose that you define a composition of your application that consists from multiple services that can be executed on cluster or on single dev machine. Doesn't matter. And with flow, you would like to define the step that happens one after other, where output from one step can be input to another step, maybe with some decision logic. And these are not long-living processes where Compose is supposed to be a long-living runtime environment. Of course, I can imagine how you can try to use, I would say, abuse the Compose. Okay, it's not for this purpose.
Okay, are there any other questions? Feel free to type them in the chat box if anyone else has something they'd like to ask. No? Okay. Well, as for, next steps, if you think of any other questions, obviously reach out to us. I would encourage you guys to, create your own Codefresh account at www.codefresh.io and give it a spin and start, building, testing, and deploying Docker images. And also, some resources for more information on containers and Docker-driven development and workflows. You can check our blog. And also, we have a page for where we're going to be posting videos about Docker Compose and other topics that you guys are interested in on our Container Academy page. So you can go to our website for those. Follow us on Twitter. I also would encourage you to create a Cloud66 account and give that a spin. And if you guys have any questions, you can reach out to Daniel or Alexei or myself, and we'll definitely make sure to answer those after the webinar. And next week, we are going to be hosting another webinar, Intro to Codefresh YAML, where we'll be showing how to simplify complex workflows using Codefresh YAML. So, if you want to learn about how to use a YAML file, the benefits, use cases, and how to write one, I would definitely encourage you to register for this event. You can go to bit.do/YAML, and that will be next Wednesday, February 15th at 9 a.m. Pacific Standard Time. So we hope to see you all there. Thank you guys so much. We're glad you could take the time out of your day to talk about Docker with us. So we'll hopefully see you next week. Have a good one.
Have a good weekend.